Let's talk a little bit about statistics and how to work with them when you come across them in an article. We're still on March 16th, week 10. I'm going here to topics. And I have down here, I've already talked about persuasion and fallacies. I'm here now on statistics and just a couple of points. There was another number one item here that was a dead link. I had to take it out. I apologize for that. Probably the most famous text on working with statistics is this one, How to Lie with Statistics. Before I get into this, I want to say that probably the best thing you could do in an ideal world is to find somebody who has official specialized training and education in statistical methods and research. Usually kinesiology, sociology, psychology students have some of that, but that's where you want to be. Mathematics, of course, as well. However, if you can't get somebody like that, there are some strategies you can use to interrogate a text to see, to determine whether or not it's a valid argument. And I guess you need to remember not to cave and just roll over when you see statistics and give up, because that is really not how it should be, and there are ways to interrogate. So let's start with this. This is a link to that very famous textbook. It comes up like this on the top left here. Chapter 10 is actually page 122, so I'll just type in 122 and press enter. For some reason it takes me to 123, I don't know. But chapter 10 has got a lot of useful information in it, particularly a set of questions that you can use to ask a text that has a heavy statistical basis as evidence for its case. And it's in a series of questions. This question here, who says so? One of the questions you want to ask is who is doing the research, who is funding it, who is sponsoring it. If it is an ad about cigarette smoke and it's funded or conducted at a laboratory that is sponsored by the tobacco company, then you know that there might be something suspicious. I just want to remind you, when we were talking about persuasion, however, that the ad hominem argument basically says that the character of a speaker or someone or something making an argument is not necessarily connected to a false argument, and that the ad hominem argument is a fallacy, because no matter how biased you might be in theory, it doesn't take away the fact that you still might be biased. Well, this is the other side of it. Yes, you might be biased as well, and so that's one question to ask for. He's got other questions here. How do you know that the research is sound? It's another question down here. Sorry for all the scrolling. Where is it? Right here. Does it make sense is an interesting chapter in this book, because he talks about, here it is here, a man named Robert A. Dufour put the FLESH formula to trial on some literature he found handy. And this is the FLESH readability. See here, Rudolf FLESH readability formula. Well, we've already talked about it in this class. Anyways, there is a discussion of how somebody did a statistical readability study on a couple of pieces of prose, and in fact came up with a false conclusion using that empirical data. So you might want to take a look in detail at that. As I say, this is a particularly useful chapter. You can make your way through the text, and whatever you can find from it is great. This link, How to Evaluate Bad Statistics in Research Methods, right here, is also helpful. This is an interesting argument. Was the hypothesis falsifiable? If something can't be phrased as a statement that can be proven or disproven using observation or deduction, you can't study it scientifically. So it has to be binary. It either has to be something that is true or false and nothing in the middle. Otherwise, it's not a legitimate study. Sample and population, you want to take a look. We call this the N factor, capital N, which is short for number, how many were in the study. So for example, I could say, I did a survey of how many people preferred chicken to beef, and 50% of those surveyed said that they preferred beef. Well, how many people did you question? Well, I questioned 2. 1 is 50% of 2. So 50% sounds a lot more convincing than 1 out of 2 people interviewed. So how big a population was studied? Who were the people in the sample? Did you pick enough representative groups, male, female, old, young, educated, not educated, black, white, Asian, Indian, whatever? Do you have enough variables? And do you have a way of randomly selecting that population? The methodology is very important. You can only test for one variable at a time. So you have to have what's called a control group that basically looks like your sample group, except that the control group is not exposed, as it says here, to your experimental variable. So the example given is testing the efficacy of a drug. That's the efficiency of a drug. One group controls gets a placebo. So you have to have, from your sample population, you have to divide it into 2. One group has to get the real medication, the other group has to get what seems like the real medication, and that control group will tell you. It's a good way to counter test to see whether or not you're getting the results that you want. Look for what's called statistical significance, calculates the likelihood that the results were obtained. And then there's what's called a plus or minus. So a big plus or minus means more uncertainty, but also compared to the size of the base number. So 100 plus or minus 1 is a pretty skinny margin of error. It's basically 1%. But if you have 10 plus or minus 1, that's a lot bigger a margin of error. That's 10%. And so you want to look for that. There are some further resources here that you can also use to do that. And this article I also found particularly useful, 7 signs that statistics aren't accurate. Again, this is intended to give you some tools as a way of getting in. This is a very important one. It's sort of similar to what we saw before. Statistics benefit the group who collected the information. So you have to make sure that the work is scholarly and published by a university. The whole point, if you remember, about scholarly writing is that it provides evidence against itself as well. And that is part of scholarly thinking. Otherwise, you have what's called propaganda. So you want to double check the background of the study. We've seen here before the sample size is small. Margins of error are too large. The samples are defective. Sometimes incentives can distort the results so that you pay people to come in and participate in the survey, and they often think that, they often think that they're expected to provide an answer one way or another. Context is also important. Let's see. Yeah, under what conditions was the study conducted? Was it funded by a particular group? Was it conducted in a small geographic area? Was it conducted across the United States, for example? Those kinds of things. Also here, the statistic flies in the face of precedent. If you know based on your own experience that other research has proved different from this or contradictory to this, you're going to have to take a second look. I'm just thinking, for example, statistics that tell us, people who exercise regularly and don't eat red meat are 4 times as likely to live 5 years longer than those who don't, or something of that effect. If you see anything that digresses or diverges from the studies that you've seen before, you should be suspicious. It's not that that research might be wrong, but when it goes in the face of precedent, sometimes it can be worth a second look. So keep that in mind. And this is useful also. Use other studies on the same subject as a cross-check. So you don't really need to necessarily to understand the methodology. If you have other statisticians and researchers who understand the methodology critiquing the particular text that you're working with, because then they've done your work for you. So I hope that gives you some insight into statistics. The main thing I want you to understand is not to be bullied by them, to be brave, to ask questions, to use these guidelines, and to challenge the results of statistics that you see in various articles.